Hey everyone, in this video we are going to represent three algorithms we are implementing for our sequence game AI agent. The first one is Minimax with alpha beta, the second one is heuristic search, the third one is Monte Carlo tree search.
Hello everyone, we began by integrating Minimax with alpha-beta pruning to enable true adversarial planning, looking 4 moves ahead to guard against optimal opponent replies. We ran experiments at 1, 2, and 4 depth. While 4 depth significantly outperformed shallower searches, it also triggered exponential node growth. With only 0.95 seconds per decision, we frequently hit our time budget. Moreover, sequence's hidden cost nature makes Minimax must lean heavily on our evaluate board heuristic. In practice, defeating an opponent driven by the same heuristic proved extremely difficult under strict time constraints. Therefore, we concluded that a pure heuristic agent centered on evaluate board offers the most reliable real-time performance.
Hi, this is Dylan. Let me quickly share the key ideas behind my heuristic search agent. First, it's goal-aware. If it can either take all 4 center squares or make it 5 in a row, it just started immediately. No further search needed. The aim is to win fast or secure the center. And second, placing a chip and picking a draft card are treated as 2 totally separate actions. I score each one independently and add them up. This keeps the choice unbiased and always picks the best overall move. Third, jack cards are handled specially. The agent avoids playing a jack card unless it's truly needed, but really values when picking one up. That way, jacks are saved for most important situations. And fourth, any move that blocks the opponent from making 5 in a row using jacks or normal chips gets a big score boost. My agent will always use whatever it takes to prevent a loss, even if it means spinning a jack. And finally, the center strategy is only active when the center is empty or just one player in there. If both sides have chips in the center, my agent shifts focus to other strategies. Those strategies help my agent balance offense and defense effectively.
Okay, the most interesting point we found in Monte Carlo tree search is we are using a sequence feature extractor which combined with the selection. We have a 6-dimensional feature vector, which each feature is dependent on the state and the actions. It's to some extent like the heuristic values, and we will use them combining with UCBTB and multi-unbounded to select the actions that give us the best Q values. And for the future improvement, for Minimax, we will consider iterative deepening or use more layers, since currently we only use 4 layers, which probably might not be enough. And for some heuristics, we might use a smarter strategy, like consider more values that could contribute to our heuristic using more advanced algorithm like dynamic weight learning or multi-step integration. Might also consider combining some simulation and considering the next steps, not only considering the best action for the current step. And for MCTS, we'll probably choose deep Q network to train more representative features and based on more comprehensive game states and actions instead of approximation. Yeah, and we could also not only use a random action to simulate opponent's behavior. Instead, we might consider the opponent to get the best actions as a simulation, And finally, we use heuristics for its best performance amongst the 3 algorithms. Yeah, and that's the end of the presentation. Thanks everyone for listening.